Very good afternoon, students. I hope all are doing good, staying safe at home. The second wave of this COVID 19 has started, so please don't be careless. Stay in your home safely, don't go outside unnecessarily. Even if you're going, make sure you're following all the safety measures. Wear mask and use sanitizer wherever you're going. So, this chapter, Basic Concepts of Chemistry and Chemical Calculations, we have been seeing for the last 1 week. So, last class we discussed about the molecular formula and empirical formula, how to calculate the molecular formula and empirical formula from the percentage that is provided to us. I hope you all understood. Very basic sum I gave you as homework. I hope you all did that. And again, I'm saying very few are irregular in sending your assignments. So, before I take any serious steps for you to do the assignments, kindly send your assignments on time. Today we are going to see stoichiometry calculations and limiting reagents. So what does this stoichiometry mean? So stoichiometry means it is a relationship between the reactant and products. So how the reactant and product in the balanced chemical equation, they are related in terms of moles. We are going to see that. So for example, stoichiometry means we all prepare, we are cooking so many dishes. Your mother cooks so many dishes at home. She know the calculation of addition of salt, chili powder, water to the food whatever she is cooking. For example, if she is making biryani for 4 people, if she is going to add 1 glass of rice, means how much of water to 1 glass of water, she will know very well. In case if she is going to make it for 16 people, what she will do, the same 1 glass she will multiply it into 16, and the same the water amount also she will increase. So she will just increase the quantity depending upon the reactant, that is the rice is a reactant here, that is she is taking to make the product, the make biryani. Okay, same way, one example which is given in your textbook is preparation of kesari. For making 6 cups of kesari, how much rava is needed? So for example, here they have given, they have said to make 6 cups of kesari, 1 cup of rava, 2 cup of sugar, half a cup of ghee, nuts and dry fruits, quarter cup. So this is for 6 cups of kesari. So if you want to make only 3 cups of kesari, what you will do, you will just reduce this into half. That is half a cup of rava, 1 cup of sugar, then half of ghee, and quarterly half of that nuts and dry fruits. If you want 12 cups of kesari, what you will do, 2 cups of rava, 4 cups of sugar, 1 cup of ghee, and half a cup of nuts and dry fruits. So we are increasing depending upon the quantity whatever we are in need of. Yes or no? So for 6 cups of kesari we need 1 cup rava, means how much is needed for 24 cups of kesari, we have to calculate. So இந்த calculations இவ்வளோ தேவையான எவ்வளோ நம்ம amount எடுக்கணும், எவ்வளோ concentration எடுக்கணுன்றதை calculate பண்ணுறது தான் it is called as stoichiometric calculations. So they have given here for 6 cups of kesari. So from the above information we can able to calculate the amount of ingredients that is required for the preparation of 3 cups of kesari. எப்படி நம்ம prepare பண்ணுவோம், you have to take in the numerator for already which is you have prepared. From 1 cup you have got 6 cups of kesari. For 3 cups of kesari, what you will do is that 1 cup rava on the top and 6 cups of kesari, and how much number of you needed, 3 cups you need, so that should be on this side. So if you cancel this, you will get half a cup of rava. These calculations are very simple. So in case 3 cups of rava if you are getting, means how much cups of kesari. So all these are just like analogy only. இவ்வளோ இருந்தால் எவ்வளோ தேவைப்படும், இவ்வளோ குக் பண்ணணும்னா how much of amount of ingredient you need ன்றது தான் simply they have given for you to understand. So stoichiometric means it is nothing but to make this amount, இவ்வளோ amount செய்யறதுக்கு எவ்வளோ amount of நம்ம reactant எடுக்கணும். 500 gram of what is this, for example any compound, if you like methane 500 grams நான் ப்ரிப்பேர் பண்ணனா எவ்வளோ amount of carbon and hydrogen நான் எடுக்கணுன்றதை கண்டுபிடிக்கிறது தான் stoichiometric calculation. So we can extend the same calculation for a chemical reaction, that is stoichiometric calculations. இப்போ நம்ம கேசரிக்கு பிரியாணிக்கு அந்த ஒரு எக்ஸாம்பிள் பார்த்தோம்ல, the same concept we can extend to chemical calculations. So we will see what is stoichiometric means. In Greek, stoichion means element and metron means measure. So elements measure பண்ணி identify பண்றது தான் stoichiometric calculation. Stoichiometry gives a numerical relationship between chemical quantities in a balanced chemical equation. So numerical relationship, இவ்வளோ amount எடுத்தா எவ்வளோ amount கிடைக்கும்னு numerical valuesல 5 grams எடுத்தா 16 grams கிடைக்கும், 20 grams of இந்த reactant எடுத்தோம்னா நம்மளுக்கு 500 grams of product கிடைக்கும்ன்றத நம்ம calculate பண்ணி படிக்கிறது தான் stoichiometryயோட idea. By applying the concept of stoichiometry, we can calculate the amount of reactants required to prepare a specific amount of a product and vice versa using balanced chemical equation. Let us consider the following chemical reaction. Carbon and oxygen, they react to give carbon dioxide. So from this equation, we learned that 1 mole of carbon reacts with 1 mole of oxygen to form 1 mole of carbon dioxide. இதிலிருந்து என்ன தெரியுது? 1 mole of carbon, 1 mole of oxygen and 1 mole of carbon dioxide product கிடைக்குது. So 1 mole of carbon is equal to, that is 1 mole of oxygen, which is similar to 1 mole of carbon dioxide. So இது நம்ம similarனு சொல்லக்கூடாது. The symbol means stoichiometrically equal. 1 mole of carbon is stoichiometrically equal to 1 mole of oxygen, which is equal to 1 mole of carbon dioxide. So we will see few calculations of stoichiometric. So this is the definition of stoichiometry. Stoichiometry is a quantitative relationship between reactant and product in a balanced chemical equation in moles. The quantity of reactant and product can be expressed in moles or in terms of mass unit or as volume. These three units are interconvertible. So in the units நம்ம எப்படி interconvert பண்றது? Mass நம்ம வந்து number of moles க்கு convert பண்ணனும்னா you have to divide that by molar mass. If number of moles should be converted into volume, means it should be multiplied by 22.4. Number of moles mass convert பண்ணனும்னா it should be multiplied by molar mass, and number of moles volume and number of moles convert பண்ணனும்னா it should be divided by 22.4. Very important problems could be asked from this part. Now let us explain these conversions by considering the combustion reaction of methane as an example. The balanced chemical equation is methane reacts with oxygen to give carbon dioxide and water. So if you see here, 1 mole of methane, 2 mole of oxygen, 1 mole of carbon dioxide and 2 mole of water is produced. So what you have to do is that stoichiometric coefficients, first row, reactant and product, you have to split these two columns. In stoichiometric calculation coefficients la, number of methane 1 தான் இருக்கு, oxygen is 2, carbon dioxide you are having 1, water you are having 2 moles of water. Mole relationship if you see means 1 methane, so 1 mole, 2 oxygen, so 2 moles, 1 carbon dioxide, so 1 mole, 2 water, so 2 moles. Mass relationship, number of moles into molar mass. Mass relationship enna pannom, number of moles irukku, we have to just multiply that with the molar mass. Molar mass of methane is 16. How it is 16? For carbon it is 12 and for hydrogen it is 4. 12 plus 4 will be 16. So 1 into 16 will be 16 gram. And then mole and mole inverse will get cancelled. So gram alone will be there as a unit. Okay. And then for oxygen is 16. So 2 oxygen are there, it is 32. So 2 into 32 will be 64 gram. Carbon dioxide it is 44 because 12 plus 32 will be 44. So 1 into 44 will be 44 grams. And for water it is 18. 18 into 2 moles of water it will be 36. So mass of reactants is equal to mole into molar mass of reactants and volume of the product. So what we have to do is that 1 mole of any gas that is occupied by a volume of 22.4 liter at 273 Kelvin and 1 atmospheric pressure. So methane it is 16 gram, oxygen is 64 gram, and carbon dioxide we are taking it as a 1 mole, no, we are taking it as 1 mole of any gas will occupy 22.4 liters. So 22.4 liters எடுத்துக்கணும். Water it is 2 moles, so 2 into 22.4 liter will be 44.8. So next volume relationship பாத்தீங்கன்னா, since all these are gases we have to get the volume relationship. எல்லாமே gaseous stateல இருக்கு. So multiply everything with 22.4 liters with this coefficient. So 1 mole into 22.4, 2 mole mole into 22.4, 1 mole into 22.4 and 2 mole into 22.4. These are the stoichiometric calculations. Now based on this calculation, we are having few problems. How many moles of hydrogen is required to produce 10 moles of ammonia? 10 moles of ammonia நான் prepare பண்ணணும். அம்மோனியாவோட ஃபார்முலா என்ன? Ammonia formula is NH3. So 10 moles of ammonia prepare பண்ணுறதுக்கு how much of hydrogen, அம்மோனியாவில் hydrogen இருக்குது. So how much of hydrogen will be needed to prepare 10 moles of ammonia ன்றதை கண்டுபிடிக்கிறது தான் இந்த question. The balanced stoichiometric equation for the formation of ammonia is, sometimes they will give this equation, sometimes they may not. So N2 plus 3H2, 2NH3 all are in gaseous state. So we are going to calculate now. As per stoichiometric equation, to produce 2 moles of ammonia, 3 moles of hydrogen is required. So in the balanced equation வச்சு பார்க்கும்போது 2 moles of ammonia prepare பண்ணுறதுக்கு 3 moles of hydrogen தேவைப்படுது. So to produce 10 moles of ammonia எவ்வளோ தேவைப்படும்? Okay, so 10 moles, 2 molesக்கு 3னா 10க்கு என்ன வரணும் அப்படின்றத நம்ம calculate பண்ணணும். ஸோ நம்ம ஃபஸ்ட்டு எப்போவுமே இந்த ப்ராப்ளமில் ஒரு சிம்பிள் ஒரு ட்ரிக் என்ன அப்படின்னா 3 moles of hydrogen and நியூமரேட்டரில் வச்சிடணும், which means எது நம்மளுக்கு ஆல்ரெடி தெரியும். ஃபஸ்ட்டு பார்ட் ஆஃப் த கொஷின் how many moles of hydrogen இருக்கா, that should be in the numerator. Is it clear? That should be in the numerator. And the next part of the question, to produce 10 moles of ammonia, that should be in the it should be in the right side. ஆல்ரெடி கொஷனில் எவ்வளோ அம்மோனியா இருக்குது, ஈக்குவேஷனில் அம்மோனியா எவ்வளோ இருக்குது, 2 moles. That should be in the denominator. So what you will do, first half of the question அதில் வேல்யூ இருக்கும், that should be on the numerator. எவ்வளோ நம்மளை கேட்டிருக்காங்க கொஷனில், எவ்வளோக்கு நம்ம ப்ரிப்பேர் அமௌண்ட் கண்டுபிடிக்கணும்னு கேட்டிருப்பாங்கல்ல, that should be on the right hand side. On the denominator, இந்த right hand sideல இருக்கிற quantity நம்மளோட ஈக்குவேஷனில் number of moles கொடுத்துருப்பாங்க, that should be in the denominator. So 3 moles of hydrogen is the first half of a question. Next half of the question is to prepare 10 moles of ammonia. And ammonia already நம்மளோட balanced equation எத்தனை இருக்கோ, that should be in the denominator. After doing the simplification, you will get 15 moles of hydrogen is required to prepare 10 moles of ammonia. Calculate the amount of water. Same way, amount of water னு கொடுத்துருக்காங்களா, so water உடைய moles it should be on the numerator. And the next 32 gram of methane should be on the right hand side of the equation. How many moles already it is there in the equation, that methane should be in the denominator. So you can see here water கொடுத்துருந்தாங்களா first half of the question. So water நம்ம வந்து we have calculated for water 2H2O இருக்குது. So 18 into 2, water molecular form mass is 18 into 2 because 2 is here, so 36 gram of water, which was the first part of the question. Then the next methane கொடுத்துருந்தாங்களா second half, 32 gram of methane, that should be on the right hand side. Already நம்மளோட questionல equationல எத்தனை methane இருக்கோ அதோடைய mass it should be on the denominator, 16 gram of methane. Is it clear? Calculate the amount ன்னு கேட்டிருக்காங்க, so we have to take the weight alone. Weight have to calculate and take. So in that case we will get 72 gram of water. Now can you tell me this? How much volume of carbon dioxide is produced when 50 gram of calcium carbonate is heated completely under standard condition? How many volume னு கேட்டிருக்காங்க. So another part you have to see is என்ன கேட்குறாங்க இந்த questionல பார்த்தீங்கன்னா amount. So you have to take it in the form of gramsல எடுக்கணும். If you see this question, molesல கேட்டிருக்காங்க, so you have to calculate in terms of moles only. Third question, if you see volumeல கேட்டிருக்காங்க, you have to take it in the form of litersல தான் எடுக்கணும். So carbon dioxide is the first half of the question. So நம்ம இந்த equationல carbon dioxide only 1 CO2. So we will see what you are going to take. Standard conditionsக்கு என்ன condition நம்ம படிச்சோன்றதையும் நம்மளுக்கு தெரிஞ்சிருக்கணும். When 50 gram of calcium carbonate should be on the right hand side, already calcium carbonate எவ்வளோ equationல இருக்கோ, that should be on the denominator. So this is the balanced chemical equation. They will provide you the equation. CaCO3 will decompose to CaO and CO2. So CaCO3 ஓட mass we have to calculate, that is 100 grams per mole. You can see the calculation, 40 for calcium, 12 for carbon, 3 into 16 for oxygen, which will be 48. So 48 plus 12 plus 40 will be 100 gram per mole. At STP, CO2 1 mole of CO2 occupies 22.7 liters. Standard conditions அவங்களே கொடுத்துட்டாங்க. நம்ம லாஸ்ட் கிளாஸில் செட் ஆஃப் கண்டிஷன்ஸ் பார்த்தோம். இவ்வளோ ஸ்டாண்டர்ட் கண்டிஷன்ஸ்க்கு இவ்வளோ லிட்டர்ஸ் ஆஃப் கேஸ் வில் பி ஆக்குபைங் ஃபார் 1 மோல்னு நம்ம பார்த்தோம்ல. ஸோ CO2 occupies 22.7 at STP. So CO2 the first half of the question. So 22.7 liters of CO2. Next half is 50 gram of CaCO3. That should be on the right hand side. ஆல்ரெடி நம்மளோட ஈக்குவேஷனில் எத்தனை CaCO3 இருக்குது? ஒரே ஒரு CaCO3 தான் இருக்குது. Mass of one CaCO3 is 100. So if you cancel this, you will get the answer as 11.35 liters of carbon dioxide. Is it clear? Next, you are having a page number 15. If you see in your textbook or in a PDF, whatever you're having, page number 15, 16 and all, we are having so many problems solved already. So practice the problems one by one and please let me know if you're having any details. The only trick you have to follow is first half of the question numerator, next question part is in the right hand side, and the right hand side la irukra same nammaloda related equation la evlo irukko that should be in the denominator. The only thing is you have to look for whether it is amount, mole or volume. Accordingly you have to do the calculation. Next we are moving on to limiting reagent.